So let us start with the B part of your 2009 paper. We have already done the A part. In that we have solved 5 questions, isn't it? Let us come back to the B part. Let us read the first question. How will you bring about the following conversions, right? Very easy. Basically, your conversions are very easy because most of the students get confused with the conversions. Let us do systematically so that you will not forget that conversion. Now, what is given to us? I have to convert ethanol to 3-hydroxybutanol. So, where did you see this 3-hydroxybutanol? Basically, you have seen the preparation of 3-hydroxybutyl in aldol condensation, isn't it? So remember, we have done this in aldol condensation method. So let us do with that clue. First, what should I do? I have to take ethanol. So copy the first one. Write the question. Ethanol to 3-hydroxybutanol. Simple. Now first pick up ethanol. So ethanol is your, this is your ethanol. Done. So what should I do? When I see, I have to convert all to al. Correct? So what extra here in this particular thing, if you close this particular hydrogen, you are automatically finding the aldehyde. Yes or no? So what should I do? To take out that hydrogen, I have to add a reducing agent like copper. Reducing agent, right? It's going to take out water, left over is hydrogen. It is going to take out this hydrogen and at 573 Kelvin. I can also add PCC, pyridinium chlorochromate. So what happens? This hydrogen is lost from here. What do I get? I'm going to get an aldehyde. Simple. Now our aldehyde is ready. Now what will I do? I'm going to take that aldehyde CH3CHO. I'm going to add one more mole because I have to get 3-hydroxybutanol. I'm going to add one more mole of aldehyde. How will I write? I'm going to showing me this. This is the reaction of aldol. Write in such a way that the alpha hydrogen is adjacent to this. So how can I write this? I can write double bond O and H. It should be like this in this pattern only. I have already shown in aldol condensation. Please watch that video. What happens in the step 1? This is going to shift here. Immediately the alpha hydrogen comes and attacks this oxygen. You said no. What do I get? I am going to get CH3 single bond, your carbon, your OH, and your H is still existing, and this CH2 comes and links with this carbon. Done? Fine. So what did we get? Now let us see. They have asked me 3-hydroxy. 1, 2, 3. 3-hydroxy. I think I'm almost done. 3-hydroxy butanol, they said. 1, 2, 3, 4. I've got the answer. 3-hydroxybutanol. Simple. This is where I have to stop, isn't it? So this whole thing occurs in the presence of a base. This is important. Dilute sodium hydroxide should be provided. Then only you'll get an aldol product. I'm done. Easy conversion. Simple, isn't it? Write the compound. See which one can convert it into aldehyde. Loss. And finally, you have to write the required product. So I'm done with the first one. Yes, let us do the second one. What do they give us? They've given us to convert benzaldehyde to benzophenone. This is also very simple. How to do? Let us write first the heading. I have to take benzaldehyde. Okay. Then what should I do? I have to convert this into benzophenone. As soon as this is given to you, try to write the reactant and product. Leave some space. This is your benzaldehyde. CHO, isn't it? This is your benzaldehyde. What should I prepare? I have to prepare benzophenone. Now let me write that benzophenone here so that it is easy to me to fill the steps. What is benzophenone? This most important thing, COC6H5. This is benzophenone. I have to convert this to this. Now what is different? What is extra compared to this and that? Benzene ring is the same. Not a problem. CO is also the same, not a problem. But what is extra? Extra is your C6H5. So there should be some medium which is going to carry that C6H5 and get that and add it to this. So best thing is which something should add, isn't it? So which will undergo addition reactions? Grignard's reagent. So best important thing, pick up Grignard's reagent. C6H5 MgBr. Simple. So it is going to cleave the bond here. We very well know magnesium comes in, attacks at this point, plus and then minus. How does this compound look like? It's going to look like your carbon is here. Okay, I need this place, so I'm going to, okay, carbon is here, your hydrogen is still existing here, oxygen is attacked by MgBr. I have done this reactions in Grignard's addition of Grignard's reagent in one of the videos. Please watch that video, then only you'll understand this concept, right? The leftover is attached. Now what else is left? We are left with C6H5. Now observe carefully, we're almost close, isn't it? 10. Now what should I do? This, whenever you find adding Grignard's reagent, you have to hydrolyze the reaction first. Important. So this on hydrolysis, your H goes and adds to this magnesium. Yes, and your OH comes and adds to this compound. Yes or no? Right. How does this look now? This comes out, magnesium breaks the bond here, and I get MgOHBr. This is what we have prepared earlier. Now you have your carbon here. Yes, you still have your hydrogen existing. You still have your C6H5 existing. Now you have your OH. Now what else is extra? Just observe. Compared to this compound and this compound, CH6H5 is ready. Benzene ring is also done. Extra is your hydrogen. Correct. So if I try to perform oxidation reaction, oxidation is basically removal of hydrogen. So what should I do when I do oxidation process? Immediately that hydrogen is lost and you're left with benzophenone. I'm done. So here what should you remember? In the earlier case, I told copper 573 Kelvin. It is a dehydrogenating agent. Copper is a dehydrogenating agent, isn't it? Right? So you should not say reduction, dehydrogenating agent. It's going to remove hydrogen and prepare respective aldehydes. Okay, right. Now observe carefully. Benzaldehyde I've taken. I've compared between the product and the reactant. When I compared between both, this compound is extra. That was brought by the Grignard's reagent. This is called Grignard's reagent. That Grignard reagent being an addition product, the whole thing gets added to the benzaldehyde. This on further hydrolysis, I've got this product. I very well know compared to this and this, there's a hydrogen extra. So removal of hydrogen, that is your process of oxidation. When I do oxidation, automatically I get benzophenone. I'm done with this also. Yeah. Now, let us do the next part. What should I do? I have to do the B part of this. Such questions are called identification questions. Right? Such questions are called identification questions. Let us do this question, see whether we can do it or not. Now, when such question is given to you, try to do stepwise. How to do? First, read the question. An organic compound A has the molecular formula, this one, full stop, right? First solve that question, then come back to second one, then come back to third, then come back to fourth. Please don't try to mix up everything, right? So what did they say? There is an organic compound A which has a molecular formula C8H16O2. Okay, I have to write that. C8, 1, 2, 3, 4, 5, 6, 7, 8. Right. Then they said there are 2 oxygens. So what am I going to do? I'm going to take exactly, because it is equal in number, I'm going to take 1, 2, 3, fourth one as O2 I have to write. So what am I going to write? I'm going to write COO. That means this is an ester, isn't it? This is what it shows. Then I have to fill the hydrogens. Here 3, 2, 2 here, 3 here, 2 here, 2 here and 2. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now the formula is correct. My first step is done. So let us name this as compound A. Try to put it in a circle. Done. After that, what did they say? Let me come back to the next point. It gets hydrolyzed with dilute sulfuric acid. So we very well know your esters undergo a reaction which is reversible in nature, that is called esterification reaction. Esterification reaction. So this dilute sulfuric acid, what does it do? It's going to dehydrate, means it's going to break water molecule and add to this. Yes or no? What do we get? It's going to cleave exactly here. Hydrogen adds here and OH adds here. What do I get? I'm going to get CH3, CH2, CH2 and COH. I've got an acid. And what else did I get? I have again how many carbons? 1, 2, 3, 4. Done. What am I left with? I am left with an alcohol now. I am going to get your CH3, CH2, CH2, CH2OH. Now let us count this. 1, 2, 3, 4. Here also 4. Here also 4. 4 plus 4, 8. I'm almost done. Clearly I have cleaved the bond of ester. Done. What do they give me? It gets hydrolyzed with dilute sulfuric acid. Done. And gives carboxylic acid B. So this is B, it seems. Then they said, and gives an alcohol C. This is C, it seems. I'm done with the second statement. I have to go to the third statement. Oxidation of C with chromium trioxide also produced B. So, alcohols, oxidation of C means I have to take the C. They said oxidation of C with chromium trioxide. What is oxidation? Addition of oxygen or removal of hydrogen. So what do I get? I am going to oxidize this alcohol. I am going to concentrate on this. I am going to remove hydrogen and add oxygen. Simple. So what did they give me? Oxidation of C with chromium trioxide also produced B. Didn't I get this product? Yes, I got this product. That means C is also correct, B is also correct. Done. After that, what did they say? C on dehydration gives but1ene. Now I'm going to take, I have proved 1. I have written like this. Now I'm going to take again C. Take that C. I have to prove the last statement. CH2, CH2OH. What should it give me? It has to give me but1ene. So what should you do? To get but1ene, you have to remove water. Then only you get an alkene. How? H from here, OH from here, eliminate. When you eliminate water molecule, there's a bond existing between this and this. That's going to shift here. When you're shifting here, how does this look like? 1, 2, 3, 4. Didn't I get but1ene? What did I do? I picked up one hydrogen from here, OH from here. Yes. And finally, I got but1ene. Fill this CH3, fill this CH2, fill this hydrogen, fill this 2. Okay. So, seeing that but1ene, what are you finding? From where did I remove hydrogen, water? Yes, mistake. What is the mistake we did? I took out hydrogen from here. OH from here. I took out hydrogen from here. Remember, minus H from here, OH from here. I finally got but1ene.